Howdy, it's Mr. Pete 222 or Tubalcain again, and in this video, which is tips number 202, it's a continuation really of the previous video, which was tips 201 on how to align a rotary table with the spindle of the Bridgeport Mill, because in review now we must have the table perfectly in line with the spindle in order to do any accurate work. So I showed you how to do that already in the previous video on this rotary table, and how to set up this little chuck so it's on center. And now I'm going to change gears and mount the Palmgren rotary table on, and show you how to do that in a similar manner, and then also to center it using the coaxial indicator, which I did not show, but there's also a previous video number 188 that covers the coaxial indicator, so you may want to look at that as well. This is my Palmgren rotary table, and it's 8 inches in diameter, a little bit bigger than the other one that I had in the other video. And some of these you're going to find have an X and a Y axis on them. This one only has an axis in one direction, and I'm not going to use that. I really pretend it's not there at all, because the adjustment can be done with the milling machine table. And this is the crank, of course, that turns the rotary table itself. But as mentioned previously, this must be mounted directly in alignment with the quill or the spindle here in order to do your layout. So in other words, the center of the table needs to be in line with the center of the spindle. I know I'm saying that over and over, but it's really important. Now this table is mounted permanently also on an aluminum plate, so these are the two mounting bolts, T-bolts, and I've just got those in position, and there's all kinds of wiggle room here right now for me to adjust this. Plus I have the capability of moving it in both axes in order to line it up. And I'm going to show you a couple different methods of doing this, but first is this cheap and simple method without any indicators, and that's just using a pin here, a homemade pin, and your rotary table is probably going to vary depending on what manufacturer you have, but on the other one you will remember there was a Morse taper here. Well, on this Palmgren it isn't a Morse taper because it's a blind hole. It doesn't go all the way through. It's a 1.5 inch hole right here. So I made this adapter, which in fact is 1.5 inch diameter here, and it's 5/8 here, I believe is what it is. Yeah, it's 5/8. Now when I made this, I had a longer piece of stock, and I turned this, and then I turned this, so this is concentric with this. So you have to have an accurately made pin. Now I will put this in the collet, tighten up the collet, and show you how I'm going to get my initial alignment here. Stop the presses, stop the presses. I interrupt this video to give you a little quiz here, a little related information, as we teachers used to say and try to present to our classes. Who is this man? Who is this very, very important man to metalworking? And this is the same man. This is a bust of him, and this is a lithograph. And the only clue I'm going to give you that this obviously is dated before photography, which was about 1855 or 1850, something like that. They had photography, but before that we had to make a bust or a painting or a lithograph in order to get a resemblance of a man. But of course, you know, the camera has freed the artist. But who is this man? Now, I admit that I would not have known the answer myself if someone had posed that question to me, but when I give you the answer, I just think you'll find it interesting, and it would be interesting if there was even one person out of the 10,000 that will watch this video that did know this without any kind of research, just off the top of their head. So stay tuned for later in the video when I disclose the answer. Okay, I've mounted the pin in a 5/8 collet, as you can see, and it's important to note at this time that your milling machine head must be trammed or squared up in both axes, or all of this is for naught, because the spindle will not be coming down perpendicular to the table. So make sure you do that, and that is shown in one of my other videos way back on how to tram or how to square the Bridgeport head. But at this point, again, the rotary table is still loose, and I've got it in the approximate position so that when I bring this down, I have entered the 1.5 inch hole on the table, and I can wiggle this around still just a little bit, as you can see. I don't know if that's going to show up or not, but it's floating yet at this time. So now I can go ahead and tighten the 2 T-bolts here, and I can be assured that I am fairly close to being in alignment. Again, this is only approximate because I'm not using an indicator on this, but for most work it's going to be sufficient. So I'm bringing those T-bolts down tight. They were real loose. Matter of fact, they were too loose. Lautrec. And come over to this side, and again tighten one, then tighten the other, back and forth, the same as you would the head on an engine until it's good and tight. Then again check this to make sure that it can go in and out easily. That's going to be within 1, 2, 3, 4 thousandths, and in most cases that's good enough. But let's take a look at another way. After you have aligned it in this manner, which again is only semi-accurate, be sure and set your digital readout, if you have one, to 0 in both axes, and then you can start your layout or your machining from that point, and you know that your the center of your spindle lines up with the center of your rotary table. Now let's talk about indicating the rotary table, and I showed you in the last video how to do it with the last word indicator, and you can use about any kind of indicator you want, but a coaxial is certainly handier to use if you have one. They're kind of expensive. They come in a fitted case like this with various probes like what you see laying here, and I've selected a curved probe of about the right length. This one was too short, and there's another one here that's too long. The curved ones are used for outside, the straight ones inside of a hole, but we're doing of course the periphery of this this pin here. I put just a little oil on there to lubricate the ball. There's a little bit of a ball on the end. Now I'm not going to talk too much about this because there's another video on it, but I'm just going to show you how to do it in regards to the application of this rotary table. The beauty of a coaxial indicator, of course, is that it always faces you, the operator. You don't have to get back there with an inspection mirror or get your head around the backside. Furthermore, you're also using this with the machine running, the spindle running, turning. And it's important to note that this particular model has a maximum of 700 RPM. Now, do not run them faster than what your directions tell you. And I've got the machine set at 660 RPM. Also, there is a stem here that screws right into the side of the indicator, and as this comes around when the machine's on, it has to have something to hit against. So I've got an indicator stand over here, magnetic base, and it can hit that. Some people actually hold this with their hand while they're doing it. I don't recommend that for beginners. Before you begin using this indicator, you want to try to get the alignment here as close as you can, possibly by using a pin like this, or put a cutter into the collet and bring it down into the center of the hole here, or something to determine that you're approximately on center, because if you're 1/4 of an inch off or 1/2 of an inch off, it's beyond the capacity of this indicator here. So, and again, this is 1.5 inch, and you're better off using the indicator on a large diameter down here rather than up here on the stem, although that would work as well. So that being done, we'll get this cleared off, and I'm going to run it at 660 RPM, and I'm going to manipulate both the X and the Y axis here on the milling machine table. I'm not going to touch this at all until it zeroes out first in one axis and then in the other. But if they're too far off, you may be confused by which crank to turn to center it. So it does take some practice. So if you're new at this, or you just buy one of these, practice it just with a piece that's in the vise until you get used to it. You can also zero the dial out if you want, but that won't really be necessary. Now when I first turn the machine on, you're going to see that the needle fluctuates wildly. Now if it's just all over the place, then your initial setting is too far off. So you want to be within, I would say, 10,000ths to start with. And that isn't too hard to do just by eyeballing it. I have dimmed the house lights just a little bit to cut down the glare on the indicator face here, so I think you can see a little bit better now. So I'm going to turn the machine on. And you can see that that needle is all over the place. So now I'm first going to move the X-axis and see if I can get rid of some of the fluctuation. That's a little better. And now the Y-axis. And then the X-axis again. So I'm actually moving both cranks. Now I'm concentrating just on the Y, and you can see that the needle has virtually stopped. The machine's still running. You see just a little bit of fluctuation, perhaps a half a thousandth or a quarter thousandth, and some of that may even be due to the fact that the pin down there isn't even perfectly round. It's a possibility. Another thing now, make sure you don't run the machine too fast because it can damage the instrument, but another thing that can happen is that centrifugal force will cause the probe here to spin out, almost like it would on a little governor, a fly ball governor. It's wanting to spin out. So now I can be assured that the spindle of the milling machine is in virtually perfect alignment with the center of the rotary table. Off camera I finessed it just a little bit more, and you can see that I'm really right on now. There's no movement of the needle at all, and you might say, well, you got the probe away from the work. No, the probe is still touching the work. And I did zero out the dial. Doesn't really make any difference, but I put it on zero. And looking up at the digital readout, I zeroed that out for a reference. And then I told you this in the other video, but what I often do if I'm working on a job, I keep the digital readout on, and that in memory, until I have completed the job, even if it's more than one day and I just leave it on overnight. It's important that you do not fiddle with the other cranks on the palm drum if yours has more than one crank other than the rotary table. Some of them have the XY, and some of them are even tilting tables. So they made a lot of different models of the palm drum. So, now that you've seen me use the coaxial indicator and see how easy it is to use, and it has a lot of other applications as well, not just with a rotary table, you may want to buy one, have one in your inventory, in your toolbox for just such a job. They are slicker than a whistle because you do not need a mirror or to crank your head around, but it does take a little bit longer to set them up. And one thing I do not like about them is that you have to drop the table down quite a ways in order to fit this in, because they're pretty thick here, and you couple that with the probe of the appropriate size that you need for your job, and you have to crank the table down quite far, but that can be easily overcome, especially by you younger guys. So I hope you enjoyed this series of videos on how to set up rotary tables, and I hope that you understand how important it is to get that on center. Now, if you are using a 3-jaw chuck on top of that, let's take a look at that real quick. Before you use your rotary table, of course, there has to be some way to fasten the work, whatever it may be, to the rotary table, and in many cases you'll be clamping it directly to the table using T-bolts or hold-down clamps or whatever. But I often use a 3-jaw chuck to hold round work when I use the rotary table, and in this case this little 4-inch buck chuck is most handy. And it's a pretty accurate chuck, so what I'm doing here, it depends on the total run out of your chuck, but and I'm not sure what it is other than this chuck is fairly new and in good condition, even though it has some spots on it. But here's how I do it, and then we'll confirm it using the indicator. But I put a 3/8 dowel pin in the collet, and I use a 3/8 simply because I have a 3/8 shank on the coaxial indicator, so I didn't have to change collets, which is always a nuisance or an extra step. But what I've done here, and this just floats around, it's going to be held by 2 bolts, and this is shown really in the other video, and it's not much different than that. It's just a different rotary table, but allowing this to float. And it's important to remember now that my DRO is still set at 0. I haven't moved a thing. And if I did accidentally bump one of the cranks, I could quickly get back to the home position, but you should lock your table in both axes so it stays there, at least for now. And what I'm going to do now is, I told you this floats around, bring this down into the chuck. Now as I tighten the chuck, you might even see that this is moving around and self-centering itself. After all, a scroll chuck is self-centering. So with that just snug, I can go ahead and tighten the 2 bolts. Then, for all intents and purposes, you are ready to begin your work, whatever it may be. However, just for the sake of interest here, let's go ahead and put the coaxial indicator in there and see how accurate it is. Now, if we're inaccurate, it's probably due to the run out of the chuck, however much that may be. But you know, we know that 3-jaw chucks are often off 2 or 3 thousandths, even when they're the cheaper ones are brand new, for that matter. So let me put the coaxial back in after I tighten these 2 bolts. Stop the presses again. It's time to disclose the identity of our mystery guest for tonight. And you were right if you guessed Henry Maudsley. And he lived from 1771 to 1831. And his claim to fame, although he did many inventions and developments, is that he developed the first screw cutting lathe. And that's about what it looked like in 1797. And there's another example of it in about 1880 as it developed into more of what we know it today. Of course, the regular bow lathe where we could turn wood, that was around for a long time. But the fact that there was a connection between the spindle and the tool, and it could be moved at a certain rate, allowed you to cut screws. And that's what was so ingenious about Henry Maudsley's invention. On with the show. I dimmed the house lights again to reduce the glare. Be very careful when you remove your coaxial indicator. If you got both hands up on the top of the head, one on the brake and one on the wrench, that you don't drop the indicator, and I'm sure you'll ruin it. So just be careful when you take it in and out. Now I put the shorter probe in there, and that's the same 3/8 dowel pin. It's ground. We know it's accurate. I don't know if I pointed this out to you, but when I turn the machine on, see, this is going to swing around and it needs to hit something so it doesn't continue to spin. So again, that's the purpose of that. Alright, let's turn it on. I don't expect it to be perfect, but we know that the table is perfect. If there's any run out, it's in the chuck. Or did I allow the chuck to slip a little bit on the table when I tightened it? Who knows? There we go. And sure enough, there is some fluctuation here. And how much? Well, it looks like it's about 2 thousandths. You see, I brought the zero around there. It's about 2 thousandths, which really is just 2 human hairs, or 1.5 human hairs, so it's not very much. So for all intents and purposes, this is going to have to do for most of the jobs that I do on the rotary table. Because 2 thousandths isn't very far off, but there are times, of course, when you want it to be dead on or perfect, especially in die making. I finessed and fiddled around with this thing for about 5 minutes off camera, and I have it really, if you look at that needle there, within 1/4 or 1/2, probably 1/4 of a thousand. So that's really, for all intents and purposes, dead on. And I'll show you how I did that. What I did is to loosen up the 2 bolts, but before I did that, I oriented the T-slots in the rotary table so that they align with the X and the Y axis. Again, loosen these up just a little bit, and using my brass hammer would tap it ever so lightly in one direction and the other to reduce that, and then of course again in the Y-axis here. But that did take quite a bit of trial and error and more time than I would have wanted to spend on it, but I got it pretty darn close now, and I'm happy with it. And then I tightened those back up, and it moved just a little bit, and so on, and I finally got it to where I want it. My digital readout still reads 00, so this thing is pretty much dead on now and ready to use. So that concludes this video on how to set up the Palmgren rotary table, and then how to set it up also with the 3-jaw chuck on top of it, and using the coaxial indicator. So hope this was useful to you and made some sense, because I probably glossed over a little bit some of the uses here of the setup here on the coaxial indicator. And if you don't have one, again, you can use any other kind of indicator. It's just the beauty for this, especially with the demonstrations, that all faces the camera or the operator of the machine. So with that in mind, this is Tubalcain saying have a good day, thanks for watching, and so long for now.